In the last section, we talked about descriptive research, which sometimes gets included with correlational research as they both involve measured variables. However, descriptive research is only looking at a single measured variable and therefore doesn't actually allow us to make any connections or comparisons between more than one variable.
So we might instead choose to do correlational research, where we have two or more measured variables. So we're still sticking with measured variables, which means that a lot of the stuff that we used previously for the descriptive research section still counts here. But unlike descriptive research, where we're just measuring and describing, now we're also adding in that interaction, that relationship between our two or more measured variables. So we're now saying, okay, we've measured two things. Do they relate to one another? And we have to keep in mind the sort of famous statement that correlation does not equal causation, meaning that, yes, these two variables might have a relationship, but we don't know the nature of that relationship. We don't know if A causes B, or if B causes A, or maybe A and B are unrelated to one another and are both being influenced by some other variable C. With correlational research, we can't differentiate between those three options without very specialized techniques that are very, very rare and beyond the scope of this course. So we're saying with correlational research, we can only make a statement that there are relationships between these variables. This is the pattern that we see between them, but nothing beyond that. So we can't make a statement of causality or directionality. And if we're going to be talking about correlations, we also need to talk about a correlation coefficient, or R. And this is just a value that is going to describe the relationship between two variables. So R ranges between -1 and +1. So it can fall anywhere between that. You can't have an R larger than +1 or smaller or more negative than -1. So that's our upper and lower limit. This is all of the possibilities here at the bottom. We have two useful bits of information. The sign, whether it is positive or negative, indicates the direction or the type of relationship between our two variables. A plus sign means a positive correlation, and a negative sign means a negative correlation, which each get their own slides momentarily. Our second thing that we care about is the absolute value. So how big of a number is it? Is it closer to 0 or is it closer to 1, ignoring the sign? So the closer we are to 1 means that it is a stronger relationship, a stronger correlation. The closer we are to 0 means the weaker the relationship. Our sign has nothing to do with the strength of that relationship. The sign only tells us the direction. So, positive correlations. This is when we see that as one of our variable increases, the other variable tends to increase too. And you'll notice I'm trying to use very neutral language because we can't say the directionality. We don't know if one variable increasing is causing the other to increase, so we say it very neutrally. So an increase in one relates to an increase in the other. The more birds I have, the happier I feel. And it could be that having more birds makes me happier, or it could be that being in a good mood makes me go out and buy birds. Either could be the case. We don't know from a correlation. But if we're looking at a positive correlation, our R is going to be larger than 0, and it will go up to that limit of positive 1.0. So any of these values would indicate a positive correlation. And I include the visual because the numbers didn't necessarily click for me until I could get a number line, which feels a little bit grade school, but actually works for me. Our negative correlations are the other side of our number line. So R that is sort of below 0 all the way to our negative limit of 1.0. And so here, an increase in one of our variables is going to relate to a decrease in the other. So a mismatch here. So the more work I have, the less happy I am. And it could be that working makes you unhappy, or it could be that being unhappy makes you do more work, or something like that. And then there we go. And then the last option is a zero correlation or a null correlation. It just means that our R is 0 and there's not actually a relationship between our two variables. So they don't correlate with one another at all. And once again, if you are a visual individual and like graphs, here's a couple of examples. So we can see a positive correlation here. So if we drew a line of best fit between these two, we'd see that a lower score on X is also a low score on Y, whereas a high score on X is also a high score on Y. And this one makes sense. We have hours of studying versus grades. So the more you study, the better grades you have. Or it could be that those students who have high grades are also more motivated to study. Directionality, not guaranteed. In the middle here, we have sort of this cloud of data, and it would be really difficult to put a line through that. So we can't really go this way and say it's any better than going the other way. It's not positive, it's not negative. This is a zero correlation. There's no relationship between how many apples you eat and what grade you get. It makes sense. And then a negative correlation here showing that downward sort of trajectory. So a low score of Y matches a high score of X. A low score of X is a high score of Y, that mismatch between the two. And then just to show that strength, I included this diagram because we have, yes, a positive correlation and a negative correlation, but here we have a positive correlation where each of our data points are more spread out. So what that means is that because these data points are clustered closer to that line, this is a stronger positive correlation. So probably maybe a 0.8. Whereas over here, where they're spread out like this, it's still positive. We can still draw our line. However, they're not as close, which means it's a weaker relationship, means it's closer to 0. So probably, let's say, a 0.3. And you'll notice that when we have the positives, the plus sign is sort of assumed, just like with other mathematics. You only really have to state the negative. So if a positive sign is left out, we assume positive. But if it's negative, there will always be a negative sign. So that's how correlations work. So we've taken stuff that we've measured, we've looked at the relationship between the two, and then we can make some conclusions based on the reported value of R. Obviously, this is a very much simplified way of doing this, or of looking at this type of research. If you were conducting these experiments, you would be running statistics in the background. So you'd actually calculate out your correlation coefficients, which once again is well beyond what you need for this course. For us, we more care on this is the value that we get after running our statistics. What does it mean? So don't worry about the calculation component here. But with our correlations, what are our advantages and disadvantages? And we'll find that this is much more than what we had with our discussion of pros and cons for just descriptive research. But for our advantages of correlational research, we get to actually see relationships that are present between these two variables. We don't know the directionality, we don't know the specific nature, but we can at least say, are they related to one another, positively or negatively? We can also use those graphs as a way to make predictions about those variables. So we can actually extend our line. So if we had here, so we have our studying in minutes, and the most that we have, this last data point, was somebody who studies, let's say, 80 minutes a night. But we wanted to predict what would be the theoretical grade performance of somebody who studies 120 minutes a night. Well, we would just extend our green line. We'd make that assumption, because it's been a strong correlation so far, that we could just extend that line and make a best guess for values that we haven't quite measured ourselves. We could also look at somebody who studies not at all and extend the line in the other direction. So this allows us to sort of look at things that we could measure in the future. Or we can make some sort of past expectations if we were looking at patterns and how things have changed over time. A whole bunch of different ways we can make use of that. It also gives us the potential to identify real world associations. So if these two variables are related, that gives us the idea that maybe we could then follow up. Maybe we can do an experiment to determine the nature of that relationship. So X and Y are positively correlated, but is it because X causes Y, or is it because Y causes X? Let's manipulate some things to see. So correlations can be really useful, especially if you have a large data set. You can run a bunch of correlations, and for all the variables that don't relate to one another, you can kind of drop those, and you can then focus future research endeavors on those that are related to one another. So sometimes correlational research can be a starting point for further experimentation. It can also be its own standalone if all we care about is the fact that things are related to one another. It's all about what you're researching and what your goals are. But of course, that brings us to our disadvantages. So once again, we're working with measured variables, so we can't manipulate these at all. And because we can't manipulate anything, we can't assume that there is a cause and effect relationship. We can't be sure of causality because our relationships might be caused by some third unmeasured variable that we weren't able to take into account. So correlational research shows an association, but not a cause, not a directionality. And so what do we mean by that? Here are a couple of examples. So if we look at this example here, where we look at birth order and intelligence, which there was actually a lot of research. People started focusing in on birth order fairly extensively for a chunk of psychological history, where there were certain things where we thought that the firstborn child tends to be like this, or tends to have this personality type, or so on and so forth. But something like this, we'd say, oh my gosh, the firstborn children are far more intelligent than those that were born later. However, what if we haven't accounted for age? So what if our firstborn is 18 and the ninth born is 11? That probably doesn't work in terms of math, but 6 is probably better. So that difference in intelligence is not actually driven by birth order. Even though there's this strong correlation, it's completely driven by age. So that extra third variable can be something that's now driving this relationship. So we've run into a confounding variable, something that sort of messes with our findings and makes it so that we couldn't state that birth order influences our intelligence or causes our intelligence to fall at some particular value. Another thing here, they were saying, okay, so instead of having one variable being irrelevant in this situation, what if we looked at, say, that third variable that instead of replacing one is actually influencing both of the variables we were looking at? So here we've said that, okay, so individuals who have better social relationships tend to also be happier. So, okay, we might assume that stronger relationships make you happy, or being happy makes you easier to form, makes it easier for you to form good relationships. But what they've said is that if we account for our personality type, we find that having some value for this personality score predisposes you to be both happier and form better relationships. And if we were able to remove the effect of this other variable, all of a sudden the relationship between these two disappears. So in this case, Z is another variable that just explains away what we thought was a relationship. So these are meant to be our precautions that you can have other variables involved. You can call them, at least for us, where we don't care too much about the nitty-gritty of the details, we can call them third variables, or we can call them confounding variables, because they are something that is the third variable in our consideration of these two, and they confound or confuse our findings. So both work, at least in the scope of this course.